All right, so this is chapter 2, day 1. This will correspond with 2.1. We're going to just do basic slope. Okay, so Roman numeral 1, definition of slope. First off, slope has a special letter, lowercase m. Anytime you see lowercase m in a formula, it automatically means slope. It's a reserved letter, kind of like pi is a reserved symbol. So what is actually the definition? The definition of slope is how steep a line is. How steep a line is. Is it really steep? Is it kind of flat? That's what slope does. Now, as math people, we have to come up with a math definition of slope, because that's how you know when you take a corner on the highway and it's snowy out that your car isn't going to fly off the edge of the curve, because somebody calculated the slope to speed ratio correctly so that you stick to the road and don't go flying off. So here's the math definition of how steep a line is. It is the ratio, which is the fancy word for fraction, the ratio of vertical change, to horizontal change. Vertical change to horizontal change. And there's a nifty little symbol for change. I've actually used it before. It's a triangle. That means change. All right, if the terms vertical and horizontal are throwing you, vertical is up or down, and horizontal is left to right. And when you're dealing with horizontal change, it's always left to right. It is never right to left. So you do it like you read. So slope, in more of a conceptual way, is vertical, and then I'm going to use the triangle, vertical change over horizontal change, and that fraction is the slope. Now, there's a couple ways to remember this, and this is a formula you got to memorize. Change in y over change in x. That's one way to remember it. Some of you might have been taught change in y is up-down change, which is sometimes called the rise, and x is the left-right change, which is called the run. So rise over run is slope. You use whatever way to remember it that works for you. Basically, though, the steeper the slope, the higher the number. So a slope of 5 is much steeper than a slope of 2. A slope of 1/2 is much flatter than a slope of 1. All right, we're going to draw ourselves a picture. So drop down about 2 inches. Okay, and you're going to draw this with me using your ruler. So you're going to have a flat part. And then I want you to go through the corners of the squares. And then it's going to get a little bit steeper. It's flat at the top. And then we have kind of a less flat coming down. Then we have a drop off and another flat part. This is our little mountain. That's the snow. You do not have to draw the snow. So it's important that not only can you calculate slope, but that you can look at a line and get a general idea for what that slope's going to be. Oh. So let's look at this one. And I picked a mountain because most of you think of slopes, you think of like ski slopes, you know, skiing on a slope. And that's actually a good way to think about it. When you have a totally flat slope, the measurement of that is 0. It has a slope, it's just at 0. So on this mountain, we have a flat slope of 0 at the bottom, and then at the end, we have another flat slope of 0. Okay, so once we hit the part where it starts getting a little bit steep, where it's going through the corners of the squares, First off, a line that goes through the corners of the squares has a 45-degree slant to it. But more importantly, when the line goes through the squares, the corners of the squares, your slope is a +1. It's a +1 because it's going up, but it's 1. Corners of the squares means 1. If it's going through the corners of the squares and it's going down, the slope is a -1. So some lines, you can just look at them and go, oh, look, slope of 1, slope of -1, just looking at how the points go through the squares. Okay, so then after that, it gets a little steeper section, and whatever this is, it's going to be a positive, larger number than 1. Maybe it's a 3, maybe it's a 4. I doubt it's as high as a 5 or a 6, but the steeper part that's not going through the corners is going to be a number bigger than 1. All right, then we reach the top of the mountain where the slope is flat again, so slope is 0. And then now we've got this gradual slope. It's kind of flat, but it's going down. Because it's going down, it's going to be negative. And because it's kind of flat, it's going to be a negative fraction less than 1. So for example, that slope might be -1/2. It also might be -2/3. So it's some kind of a negative fraction. Negative because it goes down, fraction because it's flatter than something going through the corners. All right, then we have this straight down drop off. Straight up and down vertical slope is what we call an undefined slope. And when you're calculating an undefined slope, what's going to happen is you'll have a number like 6 over a 0. And you can't divide by 0. That's undefined, which means the slope is undefined, which means the slope is totally vertical. It goes straight up and down. Now, let's not mix that up though. Come over here for another example with 0 over a number. If we go 0 divided by 7, that's just a 0. That's a slope of 0. So the only one that's undefined is a 0 on the bottom of the fraction. No matter what line you're looking at, you always read the slope left to right. Read the slope left to right. So going left to right, if it's going up, you should have a positive slope. Left to right, if it's totally flat, you should have a 0 slope. And left to right, if it's going down, you should have a negative slope. So looking at a line, at the bare minimum, you should be able to tell if it's positive, negative, or 0. All right, so that's kind of a conceptual way to look at slope. And this will help you with your work later, because if you're looking at a really flat line and you get a slope of 8, you're gonna be like, no, there's no way that's 8, because 1 is in the middle. 8 would have to be super steep, and that will help you check your work. All right, Roman numeral 2. We're going to calculate slope of a line. You can't calculate the slope of a point or a curve. It must be a line. All right, so when you calculate the slope of a line, you have to have been given 2 things. You have to have 2 points on the line. If you don't have that, you can't do the slope. So we have to designate different points. So capital P subscript 1 is point 1, and its coordinates are x1, y1. And then you have capital P subscript 2 for point 2, whose coordinates are x2, y2. So all the subscripts do is tell you if it's point 1 or point 2. So we've been given 2 points. And it could be on the line. It could be points that the line is going through. It could be 2 points that are contained in the line. Those are all different ways to say the line goes through these points. So any of those are the same. So now we've got our points. Then here is your magic formula for slope. Lowercase m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that is your main formula to memorize tonight, is to get this one to memorize. Now, if you're looking at this, y2 minus y1 is the difference in the y's. That's your change in y. And since it's up and down, that's your rise. How far did you go up? On the bottom, the difference in the x's is the change in the x, which is how far you went left to right, which is the run. So you can see how the formula is related to those other ways to think about things. All right, the vast majority of your homework tonight is going to be just like this. They're going to give you 2 points. We'll say 2, 3, and 1, -4, and they're going to say, find the slope. Okay, so first thing you want to do is designate your points. This is so that you get them into the formula without mixing them up. There are wrong ways to put the points into the formula that will get you the wrong answer. I just go in order. I'm not fancy. I just do the first one, x1, y1, the second one, x2, y2. I don't really pay that much attention to what they are. I just do them in order. So here's our slope equals, okay, using our formula, y sub 2 is -4 minus y sub 1, which is 3, over x sub 2, which is 1, minus x sub 1, which is a 2. And that is 80% of the issues with slope, is getting the right numbers into the right place. Now, this part should be pretty simple. You're going to add the tops, add the bottoms. So I get -7 over -1. Which is a +7. That's the slope. It's a very steep positive slope. Now, cool thing about the slope formula is it doesn't matter which order the points come in. So we're going to calculate the same slope, but we're going to do the points backwards. So for this one, 2, 3 is going to be x2, y2, and 1, 4 is going to be x1, y1. So when I put these in the formula, they're going to be reversed. And this shows something interesting in the algebra. So y sub 2 is 3 minus, and here's where it gets a little weird, it's minus a -4. So you have a double sign. The first one is from the formula, y2 minus y1. The second is because the 4 was negative. So if you have negative coordinates, you're going to get double signs a lot. That's just part of it. Okay, let's do the bottom. x2 is 2 minus x sub 1, which is 1. And we're going to simplify. So a negative times a negative is a positive. So 3 plus 4 over 2 minus 1. Add the tops, add the bottoms. 3 plus 4 is 7. 2 minus 1 is 1. And what do you know? We get the same one. It's still a slope of 7. So really important to understand is the points are interchangeable. So on your worksheet, if you calculate a slope and it's not on the answer puzzle, switch the points around. Just do it backwards. You won't be doing the same math, and you can double check. All right, so most of your homework is going to be like this. Here's 2 points. Calculate the slope. Write the formula as many times as it takes until you can do that formula in your sleep, because I got way more formulas to show you in this chapter. That's just the first one. All right, I'm going to go to my next page. So some of your problems, they're not going to give you the points. You have to get them for yourself. So take your straight edge and draw yourself a pair of smallish axes. I'm not going to pick big numbers. And then I want you to plot 0, 2, and 1, 4, and put a line through them. Now, in the beginning on the homework, I've actually indicated recommended points to use. The reality, though, is you can pick any 2 points that are on that line. But here's the caveat. You can't pick points that are fractional. So whatever you do for your points, you have to choose whole numbers or integers, however you want to think about it. And there's several choices on this particular line. Yeah, 0, 2, and 1, 4 would work, but I could also do -1, 0. That's a winner. What is not a winner is trying to go with like in between 1 and 2. See how this is like in between the hatch marks? That's not going to be a good point because you can't tell the difference between 1/3 and 1/2 on a graph. It's just not possible. So pick whole numbers. Sometimes it's going to be way up here and way down there because those are the only decent points there are. So be very, very picky. So we're going to pick 1, 4, and 0, 2. We're going to designate our points x1, y1, x2, y2. And then again, I'm going to have you write this formula because I want you to memorize it. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the word sub, when I say x sub 1, the sub just means subscript, small one. All right, let's put these points in here. So y sub 2 is 2 minus y sub 1, which is 4, over 0 minus 1. Go ahead and finish that. Hello? Yes? It wasn't Peyton Gatherer, it was another student. Yeah, it was Frank.
Franken.
I'd have to look it up. But yeah, it wasn't Gatherer, it was a different student. I don't know, we were doing a big walk around activity. So, there's 35 people walking around the room. Sorry. Bye-bye. All right, let's see how we did. 2 minus 4 is -2. 0 minus 1 is -1. And we have a slope of, oh, did I do the wrong point? 0, no, I did the right point. So that would be 2. Which makes sense because this is going up. It's a little steep, but not much. Okay, Roman numeral 3, last topic today. Rate of change. Now, we already did a worksheet on unit rates and rate of change. So this is not a new calculation. So we did rate of change, we did unit rates, and the deal is a unit rate or rate of change is another way of saying slope. It's just it has context. So when you do a unit rate or a slope, your steps are to find 2 pairs of data that go together, find 2 pairs of data, and then the second one is to make sure that time is usually on the bottom, which means that your time is going to be your x values when you make the points. So here's an example question of a rate of change question. This is a pretty common one. Says you are typing a paper at 5:15, you have typed 275 words. By 5:27, you have typed 660 words. Find the average rate of change. Okay, average rate of change, we did this, is the unit rate, which is the slope. Those are the same thing. And then they actually give you the units. They want words per minute. As usual, per means fraction bar. So we're going to want words over minutes, which means your words are going to be your y values. Your minutes are going to be your x values because they want words per minute. All right, so when you do a question like this one that has clock times, I have yet to find a question where you actually put 5:15 and 5:27 in. It just is not generally done. But let's write down what we have. At 5:15, you did 275 words. So that's 1 pair of data. By 5:27, you did 660 words. All right, so we're going to make these into points. And what you do is you take the early time and you make that 0 minutes. And then you see how many minutes between that and the next time. So from 5:15 to 27 is 12 minutes. So we're going to use that instead of 5:27. So now we're going to make our 2 points, making sure that minutes are the X values. So I've got 0 minutes, comma, and then 275 words. That's 1 point. And then we have 12 minutes, comma, 660 words. And there are our 2 points. So now to find the average rate of change in words per minute, I'm going to use my slope formula. So let's write it down. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's designate our points. x1, y1, x2, y2. And this is easy. This is easy stuff. It's what we just got done doing. So y sub 2 is 660 minus y sub 1, which is 275. And I'm going to go ahead and put the units on. Those were the words, over x sub 2, which is 12, minus x sub 1, which is 0. And those are minutes. So when you simplify this, you get 385 over 12, which doesn't make sense for words per minute. So you divide those and you get 32.1 words over 1 minute. And remember from what we did before, unit rate, you just use the word per. So 32.1 words per minute. So your rate of change is your slope, time always on the bottom. Okay, are there any questions about that?